I'm going to do two parts to this video. So the first part, I'm going to basically explain to you why we do what we do when we're completing the square. Basically, if you don't understand anything what is about to happen, it's going to be okay. But I want to explain it to you instead of just saying, do this and it would like magic, you can complete the square. I want you to actually maybe understand what's happening. So first of all, you need to know that a quadratic function can be expressed in vertex form and standard form. Now these are actually the exact same equation, but they're expressed differently. There's advantages to both. So this one can be easily factored and I can find the x-intercepts. This one, I can very easily see the vertex is -3, -9. So that's an advantage to be able to see the vertex right away. So it is a skill necessary for you to be successful, is to be able to switch from standard form to vertex form, okay? So let me just show you how this works. So this x plus 3 squared is the same thing as x plus 3 times x plus 3 minus 9. I think most of you would use the box to expand this. So x squared plus 3x plus 3x plus 9. So this would be x squared plus 6x plus 9, and then we have the minus 9. So then the 9's cancel, and we end up with x squared plus 6x. So hopefully now you can see that this and this are the exact same equation. So what we did here, if you look at this step right here, we actually kind of added 9 and then took 9 away. So keep that in the back of your mind when we're looking at completing the square. So what we're going to look at is we're going to go old school and we're going to think about algebra tiles, okay? So we're going to think about x squared plus 6x. So this is a big algebra tile, okay? This means this is x squared because this guy is x by x, okay? And then we're going to have 6 small ones, okay? So this guy's an x by 1, right? An x by 1, so that's an x, an x, an x. And we're going to do 3 here. So what this represents is x plus 3 times x plus 3. Well, to actually complete the square, we're missing some 1s right now. How many 1s do I need to make this a complete square? The reason why we want to make it a complete square is we want to write it like this, x plus 3 squared. Okay, because that helps us figure out the vertex. So I would need to complete the square 9 little tiles, okay? And what do we do to figure out that I needed 9 little tiles? I halved this number right here, which is the b value, okay? So because I put half them here and half them here, that gave me the 3, okay? Then I did 3 by 3, so then I squared it. So this is basically the formula of every time I am doing a completing the square process. What I'm doing is I'm going to take the b value, so watch this. I'm going to take the b value, which is 6. I'm going to divide it by 2, which is 3. I'm going to square it, so I'm going to add 9. But I can't just randomly add 9 from an equation, then I need to also subtract 9. And then I can express x squared plus 6x plus 9. That's the exact same thing. So x squared plus 6x plus 9 is the exact same thing as saying x plus 3 times x plus 3, which is the same thing as saying x plus 3 squared. So that is how we do completing the square using the algebra tiles.